Namaskar. Welcome to the channel Anka Ananda Aharan. As per the request of some of the viewers, here I am making a video for only two questions, that is Article 6.2 from the hard copy, question number 25 and question number 34. For question number 25, it is the quadratic form is given. We are expected to verify the corresponding matrix is positive definite or not. Here the question is why the first matrix is positive definite but not the second one. Observe here, we know here this formula is known to us. In the previous video I have made it. So if this is my matrix, the corresponding, if I have the quadratic form in this format, then the corresponding matrix will be this one. Observe how they are related. Just let us make it small so that it will be visible. So here how they are related. This is the first diagonal element. This is the second diagonal element. And the coefficient of x3 is the third diagonal element. Okay. So then what happens? x1, x2, 1, 2 position to 1 position is having the value d as their sum. They are equally divided, so this is d by 2 and it is d by 2, 1, 2, 2, 1. Similarly, E is divided among 1, 3, 3, 1 position as half half. Similarly, F is divided as in between 2, 3 and 3, 2 positions. So I got this matrix. Okay. So similarly, if I have a matrix, what is the corresponding quadratic form? Suppose this is my matrix A, B, C, D, E, F, G, H, K. Then A into x1 square plus E into x2 square plus K into x3 square plus 1, 2, 2, 1 position elements into x1, x2 plus addition of 1, 3, 3, 1 position elements x1, x3. Similarly, plus addition of f and h x2, x3. So, this is the corresponding quadratic form to matrix, matrix to quadratic form. This formula is already we have discussed in the video, but again, as per the public demand, I am making this video. So here, now let us discuss our f. What is f1? The coefficient of x1, x2, x3 all are 2. So the diagonal elements I have made 2, 2, 2. Now what is the coefficient of x1, x2? It is minus 2. So here I have written minus 1, minus 1. And x1, x3 is not there. That means its coefficient is 0. So I have written here 0. 2, 3 position is having minus 2. It is divided into 2 equal parts. That is 2, 3, 3, 2, minus 1, minus 1. So I got my matrix A from this F as in this format. Now here, what about the D1, D2, D3? My first D1 is the 1, 1 position element. It is 2. So which is greater than 0. Then its determinant is my D2, which is also 3, which is greater than equal to 0, sorry, strictly greater than 0. And the determinant of the matrix is this one, which gives me that it is also positive. So as D1, D2, D3 all are positive, we have the matrix is positive definite. That is the quadratic form also. We can consider the matrix or quadratic form is positive definite. Next, the second matrix for the second question. Here everything remains same, just in the 2, 3, 3, 2 position, sorry, 1, 3, 3, 1 position, the elements zeros will be replaced by ones. So what will happen? So here these are the diagonal elements, everything remains same. So here in the previous question they were zeros, but here it is 1, minus 1, minus 1. So now in this case, as usual, D1 is positive and D2 is also positive, these two values. But D3 is nothing but 0. So as D3 is 0, it is positive semi-definite, but it is not positive definite. Okay, is it clear? I hope so. Next, the question number 34. A is given like this. We have to verify whether it is positive definite, semi-definite or indefinite, what type of matrix it is. Now here let us study. First of all, let us study the question. I hope I have properly told the question, but still let us read it. Apply any three tests to each of the matrices A and B to decide whether they are positive definite or positive semi-definite or indefinite. So here what happens? This is my A. Observe here. This is positive, but its determinant first row is equal to second row, so determinant is 0. And the whole matrix, this row and this row are repeated, so the whole determinant is also 0. So here D1 positive, D2, D3 are 0. So if some are positive, some are 0, the matrix is positive semi-definite. So A is positive semi-definite. Similarly, in case of B, the B observe here, it is D1 which is positive and D2 is the determinant, this one, which is also the determinant value is 1, hence it is also positive. But D3 observe the first row and third row, or first column, third column, they are same. That means the determinant is 0. So determinant of B is 0, that means D3 is equal to 0. So this is D3. So what we got? Positive, positive, but this is equal to 0. So some are positive, some are 0. So B is also positive semi-definite. I hope this video will help the persons, those who are having doubts regarding these two questions. Now their answers, this answer might be helping them to understand. Thank you for your patient listening.